My dog got these shades as a party favor for the birthday party that they went to over the weekend. Yeah. So, dog parent life. But anyways, okay, moving on. Sorry to waste your time. Little fun stuff. Don't look at my hair. My hair's a mess. It doesn't matter. The way I look is not important. How I look does not affect my ability to teach you math. Alrighty. So, anyways, 9-2 notes. Example number 1. What is the GCF? Now, okay, greatest common factor, as we just talked about in the previous video. So we are looking at all three of these terms here, and we are trying to determine what they have in common. What factors can be taken out of each one? What's the largest number that can be divided? What do they have in common? Okay, so the easiest way I find to look at like 20, 12, and 28 is to start with the smallest one. So I'm going to start with my factors of 12, which I know are 3 and 4, 2 and 6, and 1 and 12. You could always type that into your calculator, into y equals, to not have to do that in your head. So one of these numbers has to go into all of the rest. We want the greatest one, so let's start with the greatest one, 12. I know 12 definitely doesn't go into 20, so definitely not that. 6 goes into 12, obviously, but not 20. Can't be that. 2, that's not the greatest one. Let's go to 4. 4 goes into 20, check. 4 goes into 12, check. And 4 goes into 28, 4 times 7. So, doesn't matter if 2 also goes into them. Yes, it's true, 2 does, but we want the greatest. 2's not the greatest. 4 is the greatest. So our GCF is that 4. And now, okay, looking there, remember, that's not it, because that's like middle school there, picking out the number. We got to look at what else. What else do those 3 terms have in common that we can take out of each one? Well, you might notice that all 3 of those terms have that negative sign. So I can make my GCF not just a 4, but a negative 4. But again, that's still focused on the numbers, and we have yet to look at the variables. Now, thinking about exponents and how to expand those, in this first monomial, I have x cubed, which means that I have an x times an x times an x, and then a y. Here, I have an x times an x, and in the first, or the last term, the negative 28 one, I only have one x. So each one of those has at least one x that I can take out. Couldn't take out more than one because this last piece only has 1. So that turns my GCF into a 4x. All right, and now we look at the y's. Do they all have at least one y that I can take out of each one? On first look, you might think yes, but you're wrong. Wrongo! And that's because of that pesky little y to the 0. Remember the 5th of November that anything raised to the 0 power is going to be a big fat 1. Not one y, not one x, just plain 1. Meaning that y to the 0, there's not really a y to the 0 there. There's just a 1 there. Meaning that this negative 28x is really just negative 28x and doesn't have a y at all. So I cannot take a y out of each one, making my GCF to